Symmetry. Introduction. Symmetry is an important geometrical concept, commonly exhibited in nature, and it's used almost in every field of activity. Artists, professionals, designers of clothing or jewelry, car manufacturers, architects, and many others make use of the idea of symmetry. The beehives, the flowers, the tree leaves, religious symbols, rugs, and handkerchiefs. Everywhere you find symmetrical designs. You have already had a feel of line symmetry in our previous class. A figure has a line symmetry if there is a line about which the figure may be folded so that the two parts of figure will coincide. You might like to recall these ideas. Here are some activities to help you. Enjoy identifying lines, also called axes of symmetry, in the designs you collect. Let us now strengthen our ideas on symmetry further. Lines of symmetry for regular polygons. You know that a polygon is a closed figure made of several line segments. The polygon made up of the least number of line segments is a triangle. Can there be a polygon that you can draw with several fewer line segments? Think about it. A polygon is said to be regular if all its sides are of equal length and all the angles are of equal measure. Thus, an equilateral triangle is a regular polygon of three sides. Can you name the regular polygon of four sides? An equilateral triangle is regular because each of its sides has same length and each of its angles measures 60 degrees. A square is also regular because all its sides are of equal length and each of these angles is a right angle. Its diagonals are seen to be perpendicular bisectors of one another. If a pentagon is regular, naturally, its sides should have equal length. You will, later on, learn that the measure of each of its angles is 108 degrees. A regular hexagon has all its sides equal and each of its angle measures 120 degrees. You will learn more of these figures later. The regular polygons are symmetrical figures and hence the lines of symmetry are quite interesting. Each regular polygon has as many lines of symmetry as it has heights. We say they have multiple lines of symmetry. Perhaps you might to investigate this by paper folding. Go ahead. The concept of line symmetry is closely related to mirror reflection. A shape has line symmetry when one of half of its mirror image of the other half. A mirror line thus helps a visualize of a line symmetry. While dealing with mirror reflection, care is needed to note down the left right changes in the orientation. As seen in the figure here, the shape is same but the other way round. Play this punching game. Fold the sheet into two halves. Punch a hole. Two holes above the symmetric fold. The fold is a line or axis of symmetry. Study about punches at different locations on the folded paper and the corresponding lines of symmetry. Rotational symmetry. What do you say when the hands of a clock go round? You say that they rotate. The hands of a clock rotate in only one direction, about a fixed point, the center of a clock face. Rotation, like movement of the hands of a clock, is called the clockwise rotation and the size is said to be anti-clockwise. What can you say about the rotation of the blades of the ceiling fan? Do they rotate clockwise or anti-clockwise? Or do they rotate both ways? If you spin the wheel of bicycle, it rotates. It can rotate in either way, both clockwise and anti-clockwise. Give three examples each for 1. A clockwise rotation and 2. Anti-clockwise rotation. When an object rotates, its shape and size do not change. The rotation turns an object about a fixed point. This fixed point is called the center of rotation. What is the center of rotation about the hands of a clock? Think about it. The angle of turning during rotation is called the angle of rotation. A full turn, means a rotation of 360 degrees. What is the degree measure of the angle rotation for? 1. A half turn. 2. A quarter turn. A half turn means rotation by 180 degrees. A quarter turn is rotation by 90 degrees. When it is 2 o'clock, the hands of a clock are together. By 3 o'clock, the minute hand would remain thirds, but our hand would have made only a quarter turn. What can you say about the positions at 6 o'clock? Have you ever made a paper windmill? The paper windmill in the picture looks symmetrical. But do you not find any line of symmetry? No folding can help you have coincident halves. However, if you rotate it by 90 degrees about a fixed point, the windmill looks exactly the same. We say the windmill has a rotational symmetry. In a full turn, there are precisely four positions on rotation through the angles 90 degree, 180 degree, 270 degree, and 360 degree. Because of these, we say it has a rotational symmetry of order 4. Here is one more example of rotational symmetry. Consider a square with P with one of its corners. This performs quarter turns about the center of the square marked. Figure 14.131 is the initial position. Rotation by 90 degree about the center leads to figure 14.32. Note the position of P now. Rotate again through 90 degree and you get figure 14.33. In this way, when you complete the fourth quarter turns, a square reaches its original position. It now looks the same as figure 14.31. This can be seen with the help of a position taken by feet. So thus, a square has a rotational symmetry of order 4 about center. Observe that in this case, 1, the center of rotation is the center of the square. 2, the angle of rotation is 90 degree. 3, the direction of rotation is clockwise. 4, the order of rotational symmetry is 4. The point where we have the pin is the center of rotation. It is the intersecting point of the diagonals in this case. Every object has a rotational symmetry of order 1 as it occupies same position after rotation of 360 degrees. Such cases had no interest from us. You have around you many shapes which possess rotational symmetry. For example, when you say slice certain fruits, the cross sections are shaped with rotational symmetry. This might surprise you when you notice them. That there are many road signs that exhibit rotational symmetry. Next time when you walk along a busy road, try to identify such road signs and find out about a order of rotational symmetry. Think of some good examples of rotational symmetry discussed in each case. 1. The center of rotation. 2. The angle of rotation. 3. The direction in which the rotation is affected. And 4. The order of the rotational symmetry. Line symmetry and rotational symmetry. You have been observing many shapes and their symmetry so far. By now, you would have understood that some shapes have only line symmetry, some have only rotational symmetry, and some have both line symmetry and rotational symmetry. For example, consider a square shape. How many lines of symmetry does it have? Does it have any rotational symmetry? If yes, what is the order of rotational symmetry? Think about it. The circle is the most perfect symmetrical figure because they can be rotated around its center through any angle at the same time. It has a limited number of lines of symmetry. Observe any circle pattern. Every line through the center forms a line of symmetry and it has rotational symmetry about the center of every angle.